All right, so let's go ahead and do a project of something practical. So for this project, we're going to be calculating roots of polynomials. So first, before we can actually calculate the roots of a polynomial, we need to define a polynomial as a vector. So to do that in MATLAB, we can do the following. So for example, if we type p equals brackets 3 space 2 space 1 close brackets and then semicolon, what this is doing is we can define this as a polynomial starting with x to the 0 and then ending in n plus 1. So for example, let me actually put some comments over here. So this command, what it essentially is doing, it's saying, well, I'm going to have a vector with 3 points. The point to the right of the vector is going to be, for example, x to the 0. The next one is going to be x to the 1. The next one is going to be x to the 2, and so on and so forth. So for example, this command essentially would give us a vector, or rather a polynomial, that has the form as follows. So this would be polynomial. So again, we start from all the way from the right, and that would be whatever variable to the power of 0, and then we move to the left 1, 2. So for example, this would be equal to 3x squared, and let me actually put a percentage sign over here because this is a comment. So 3x squared plus 2x to the 1 plus 1x to the 0 technically, but of course we know that x to the 0 is simply just equal to 1. Anything to the power of 0 is just equal to 1. So what this command is saying is that we're essentially going to define a polynomial using this command, and what this is doing is it's taking the first number to the right, and that's going to be to the power of 0. So whatever variable you want to the power of 0, the next one is going to be to the power of 1, the next one is to the power of 2. So if we write this down this way, this would essentially be this polynomial. So we're taking this coefficient 3, or rather, let's start from the right. So we're taking this coefficient 1, and that would be 1x to the 0. The next one 2, so that would be 2x to the 1. And the next one 3 would be 3x to the 2, or squared. So essentially, if we write this way, this would be a polynomial 3x squared plus 2x plus 1. Again, plus 1 at the end because the x to the 0 is just simply 1. Now we could also say, for example, if we wanted to write a polynomial that's x to the 4 plus 2, for example, we could write that as follows. So 1 space 0 space 0 space 0 space 2, and close bracket and semicolon, and let me put a comment over here. Again, this essentially would be a polynomial. So polynomial, and again we start all the way from the right, and that would be x to the 0, and then we move on to the left. So this number would be x to the 1, x to the 2, x to the 3, and x to the 4. So essentially this would be the following polynomial. So it would be 1x to the 4 plus 0x to the 3 plus 0x to the 2 plus 0x to the 1 plus 2 times x to the 0, x to the 0, which essentially is the same as saying x to the 4 plus 2. So again, you have to be careful how you define this. The first number would be whatever variable you're using to the power of 0, and then you move to the left to the power of 1, power of 2, power of 3, power of 4 in this case. So essentially when we define this way, this will be the same as saying x to the 4 plus 2. And let me actually rename this so that it's something different. Let's say, instead of p, let's say L. Alright, so we've defined two polynomials. The first one is p, which is 3x squared plus 2x plus 1. The second one is the one that we've called L, which is x to the 4 plus 2. And then to get the roots of those polynomials, we can simply use a function which is conveniently called just roots. So we can say roots p. So this is going to compute the roots of this polynomial. Now, notice that this notation for this command over here is the same as we defined a vector. So this is technically a vector, but when we use it in conjunction with the roots command or the roots function, then MATLAB assumes that whatever you're putting in here, even though it's a vector, it redefines that as a polynomial based on the vector parameters that you put over here. So again, technically this command here is just a vector. It's not a polynomial yet, but once we put that inside the roots command or the roots function, MATLAB knows to interpret that as a polynomial with these coefficients. Again, the rightmost point would be x to the 0, then x to the 1, x to the 2, and so on and so forth. So now if we do roots of p, we get the two roots for that polynomial, and of course that makes sense that we get two results because it's a power of 2 polynomial. Now we can do the same thing for the other polynomial, so roots L, so the roots of this polynomial, and we hit enter. And again, it makes sense that we get 4 results because this is a polynomial x to the 4, and we know from algebra that if we have a polynomial to the power of 4, then there's going to be 4 solutions to that, or rather 4 roots to that polynomial. Same thing here for this one over here. All right, so let's do one last one and we can move on. Let me clear commands and let's call this polynomial, let's say f. And I want that to be 2, 4, 2, 1, for example. So again, this would be a polynomial with the following. So again, we start all the way from the right, and I know I'm repeating this, but I just want to make sure that this is clear for you to understand. So this would be a polynomial. Again, we start all the way from the right, and that would be to the power of 0. So this would be power of 0, power of 1, power of 2, power of 3. So let's start 2x to the 3 plus 4x to the power of 2 plus 2x to the power of 1 plus 1x to the power of 0. And of course, we know that this would be just simply 1. And now we can say roots of f. And again, this is a polynomial to the power of 3. So we would expect 3 roots for this polynomial. And of course, that matches our answer over here. So again, this is just a practical way that you can use MATLAB to do some a little bit more complex mathematical operations. And again, you can get a complete list here of the description in the help menu. If I search here for, let's search for roots and let's keep going. So polynomial roots over here. And again, this gives you a thorough explanation of the roots command. And again, this is what I was talking about earlier, that when you define a vector, for example, 3x squared plus 2x plus 2 or minus 2, you can define it using this command over here. So 3 minus 2 minus 4, or rather that would be for this polynomial over here. So again, you start from x to the 0, that would be this coefficient. So you can see that we have here minus 4, and technically that would be minus 4 times x to the 0, but again, we know that x to the 0 is just simply equal to 1. And then we get minus 2, so it would be minus 2 times x to the 1, that would be this coefficient over here. And then lastly 3, so that would mean 3x squared. And then if you want to find the roots of that, you simply do roots of p, and that gives you the results. In this case, being 2 results because it's a polynomial to the second order.